Okay, in this lesson, I'm going to teach you how to solve a trig equation again with a unit circle, but our equation just looks not so simple this time. So looking at a domain here, we want to find all solutions between negative pi and pi. So this is a really tricky domain to work with. I actually always try to split it up into a negative domain and a positive domain. So my negative domain would look like this, from negative pi to 0. And then my second domain would be go from 0 to, oh, sorry, that should be an x there. Should go from 0 to positive pi. Okay? So that way it's just visually easier to see where to find these solutions on the unit circle. So looking at our equation here, we do have a tan equation, and tan is actually on both sides of the equation. So what I would do first is actually get tan x on its own. So I'm going to bring the 3 tan x over to the right-hand side by subtracting it from both sides, and I'm going to have, as a result of that, negative 3 is equal to 2 tan x minus 1, and then I'll bring the negative 1 over to make it positive, and I get negative 2 over on this side, which gives me 2 tan x on this side, and then finally tan x in the end will be equal to negative 1. So on the unit circle, you want to look at where on the unit circle is the ratio of the y coordinate over the x coordinate given as negative 1. Now, in order to get negative 1 as a ratio, both the top and the bottom should be the same, but one will be positive and one will be negative. So let's go to our unit circle here, and we'll try to narrow down our options. First of all, so let's look at all possible solutions between 0 to pi first. So since tan is negative, we need to use our add sugar to coffee rule to figure out where is tan negative. So tan will be negative in 2 quadrants, in the second quadrant, and it will be also negative in the 4th quadrant. So we actually have 2 possible solutions here. So remember, we want to find out where are the coordinates in which y over x will give you negative 1. So to find that point, you want to find out where are the coordinates the same, but a different sign. So looking in quadrant 2, you'll see this coordinate right here. If I divide those 2 coordinates, y over x, I get negative 1. So our first solution is actually very, very possible given by 3 pi over 4. And then, of course, so I'm going to actually highlight this terminal arm first of all. And then in quadrant 4, that coordinate will coincide with this point right here. Okay, so once again, if you divide these 2 points or 2 coordinates, you'll get negative 1. So a second possible terminal arm we could be working with here is in quadrant 4, and it looks something like that. Okay, so let's see here. We want to look at our domain here. We're looking at all values between negative pi and 0. So remember, negative pi, that's in the clockwise direction. So here's 0 radians, and negative pi radians is over here, okay? So going in the clockwise direction. Now, within that domain, we do have a solution. It's in quadrant 4. But be very careful here. That angle is not going to be 7 pi over 4 like it says on the unit circle. It's actually going to be equal to negative pi over 4. And if you're not sure how I got that, just look at the first quadrant. Root 2 over 2, root 2 over 2, that coincides with pi over 4. So this angle right here is negative pi over 4, and that's my first solution. So x1 is equal to negative pi over 4. And then our second possible solution is going to lie in this domain, so between 0 and pi. Now, if we go to 0 and pi, remember that's in the counterclockwise direction. 0 to pi is within that domain. And we do have a solution. Our solution is once again in quadrant 2, and that angle is 3 pi over 4 given by the unit circle. So just to conclude this, I have 2 possible solutions that fits this equation, one at negative pi over 4 and the other at 3 pi over 4.